My amazing math leads, here we go, section 3.52, graphs and applications of functions. This is our second day in this section, and I'm going to talk about something called piecewise functions. Piecewise, that means functions defined in pieces. Here, there are three pieces. There's going to be a blue piece, a red piece, and a yellow piece. And so the instructions ask you to find 6 different values. Find f of -5, -3, 0, 3, 4, and 10. And we might as well graph it too. Here's a strategy for graphing. I want you to remember this. Make sure, I think the easiest way to graph these, if you're doing it by hand, is to graph the whole piece first. For example, graph all of x plus 1. It would look like this. It's a straight line, and it wouldn't just be this part that you see right here. It would be the entire thing all the way across. Graph that. Then, as a second part of the strategy, erase the parts not in the domain. What that means is the blue piece isn't going to go on forever. It's only going to be graphed for all values of x that are less than -2. So here at the value of x for -2, we want to keep everything that's less than -2 and erase all the rest. That's why it's only this piece. It's only a part of the original. You can do the same thing here. Y equals 5 is going to be a horizontal constant line. That's the red piece. And you should, as the strategy indicates here, the strategy says you should graph all of y equals 5, but then erase the parts that you don't need. You can see in the domain of this piece, it should span between -2 and +3 inclusive. So here it goes from -2 up to +3. -2 up to +3. And you can erase all the rest. I'm going to notice that I'm even putting closed dots, filled in dots here to indicate that -2 is going to be on this piece, not on this piece. +3 is going to be on this piece, not on this piece. And if you were graphing this by hand, here, you'd have y equals x squared. You could graph the entire parabola as it goes all the way down here like this, the entire parabola, and then erase the parts that you don't need. Notice that it's defined only for, you're going to look at this, you're going to use this piece only when x is greater than 3. So here, all of the x values that are greater than 3 got kept, and everything else got erased. That's how you'd graph it by hand. Graphing it using Desmos, you would just type in them normally and then use these brackets here to talk about the condition that you want to use. Graph y equals 5, but only graph it for the x values between -2 and 3. Desmos can handle all that, and it does a great job of graphing it. How do you calculate the values? How do you actually find f of -5, f of -3? Well, you have to be very careful because you have to plug -5 into the correct piece. Because -5 is less than -2, we're going to use the top blue piece, and -3, you're going to use the top blue piece to evaluate. Because 0 is in between -2 and 3, it satisfies this condition here, then we're going to say f of 0 is going to equal 5. We're going to use the red piece to calculate. Then f of 3, same thing. F of 4 satisfies this condition. It's greater than 3, and 10 also, so we're going to use that. As you can see here in the table, the top 2 lines were using the blue piece, the red piece, and yellow piece. And you calculate the values differently depending on what piece you plug them into. Here. I want you to take a moment to make sure you've copied it all down, of course, and then also I want you to try and figure out what is f of -2. What piece are you going to use, the blue, the red, or the yellow? Be very careful and look at the conditions. And then once you've done that, let's move on. Here's another piecewise function. There are 2 pieces. These pieces are relatively standard, but these are kind of strange pieces. And let's look at the conditions. If x is not equal to -2, then you can use this. But if x is equal to -2, then use the red piece. What happens when x is -2? Well, if x is -2, then you're going to zero the denominator. If you calculate this out, this would be 4 minus 4 over 0. That's 0 over 0, and we can't figure out what that would be. There's no value. It's undefined. So if x happens to be negative 2, then just use the value of 3. And you can see the red piece gets plotted just as a single point right here, because when x is negative 2, bam, the value of the function should be 3. It's only one single point here. It's what's called a removable discontinuity. But you don't have to worry about that till calculus, really. Here you can see we're graphing the blue piece right here, and there's going to be an open dot right here because you really can't figure out what the value is. We're going to instead use it here. How did we graph that? Let me show you. X squared minus 4 over x plus 2 can be factored and simplified. Bam, we cancel all those out because there's multiplication in between. And you're just left with x minus 2. And so this is the graph of x minus 2. You can graph it. You can see that the y-intercept is negative 2 and the slope is positive 1. It all gets graphed like that. And then there's this hole that you have to make sure you include as well. Here's another really crazy function. This is called the greatest integer function. I think the title got misplaced. Yeah, greatest integer function is what it's called. Desmos calls this the floor function, and that's because basically what you're doing is you're rounding down. This is how your textbook expresses it when they want to actually write it out. F of x equals int of x. So it's the integer. So rounding down looks like this. If you have f of 1, then that rounds down to 1. There's no rounding at all. 1.5 would still round down to 1. Even 1.999999 would still round down to 1. But as soon as you hit 2, then it rounds down to 2. These three parts are all part of the same blue piece right here. They're all right here. This f of 1 is 1. That's actually this solid dot. And you'll notice that it goes along until it hits 2 right here where there's an open dot. We don't want to include the right-hand part of this piece as an open value. As soon as you get f of 2, then it jumps up. It steps up. These are steps. Here you can call them all steps. This step begins with 2 and goes all the way up until you hit 3. And then you can see that f of 3 would be the next step up. So that's how you graph that. There it is. If you were interested in a state capital to visit, I highly recommend Denver. It's one of my favorite state capitals. Head to Denver, and if you've been to Denver, then let me know, because Denver is the capital of Colorado. We'll trade Denver stories. Begin 3E2, copy the problem list, and do the first problem. I'll see you in class.